actually technically the third seminar of this semester. Some of you will know that the second seminar did not take place due to a typhoon. Okay. So appropriately, we now have a talk about a typhoon. I'm very pleased to introduce, and many of you already know him, Professor Jim Warren, one of the most distinguished and widely cited scholars of Southeast Asia. I followed Jim's work for years, in particular, of course, his famous book about the Sulu Zone. Some of you here will know that from 1981, which is also written about Singapore in the late 19th, early 20th century. The Rickshaw Cooley book of 1986. One of his books, 1987 book, sort of summarizes Jim's perspective on Southeast Asian history, a book called At the Edge of History, Southeast Asian History from 1987. He's written about a number of issues of great interest in the region, for example, about pirates as well. He's been rewarded on numerous occasions. I won't go into the details, but just an example of the kind of distinguished career he's had. Jim and I had met in New Haven many years ago, but we re-met this summer in Portugal, and he kindly agreed to make a stopover here in Hong Kong. We're very pleased you could come, Jim, and look forward to your talk. Thanks very much.
I think it would. A gentleman just asked me how I am, and I said, well, I'm above ground and mobile. But I think actually I better see it. It'll make it easier in some ways, if only for the sake of precision and clarity and pressing the button here for the PowerPoint. I thought what I'd like to do initially is just provide a bit of background or context for the presentation this afternoon. Namely, where does this study that I've been involved with now for over a quarter of a century about cyclonic storms and their place in the society and history of the Philippines, where does that fit in the larger scheme of things? So I want to introduce just very briefly a project that I've been involved with that's running over 7 years, namely from 2010 to 2017, that also involves McGill University, and it's a major global collaborative initiative, and I am one of 5 team leaders, and the theme of the project that I'm responsible for has to do with the impact of natural hazards on the Southeast Asian world over 10 centuries. And there are 6 eminent individuals that are members of the team, as well as several PhD students and 2 postdocs. And we've been working on this now for 3 years. In fact, I've just come from McGill 2 weeks ago, where the overall project, which, as I said, involves 6 teams looking at the Indo-Pacific world from the coast of East Africa to the South China Sea, came up for their midterm report review to the Social Science Humanities Research Council of Canada. One of the things that resulted out of the review, but that was already in the works over the course of this year, was a series of discussions with leading Japanese scholars at Kyoto University and at the University of Tokyo. And so that's where I've been for the last week in Japan at Todai, working on a way of extending this major collaborative initiative now that involves McGill, Murdoch, where I teach in Western Australia, to Japan now, and involving a range of sensei there in this larger initiative. But let me just introduce you to the background to the project as a precursor to talking about cyclonic storms in the Philippines. So the team that I'm involved with, and it includes Professor Anthony Reed, Professor Lee Ta-Nam, Professor Greg Bankoff, Alicia Shrieker at Leiden University, and a number of other individuals, are concerned with the fact that people in the region, here mainly Southeast Asia, have periodically, their societies, their institutions periodically have been decimated by climate-related and other natural hazards, including typhoons, floods, drought, earthquakes, volcanic eruption, and tsunami, and associated famine and disease. So this project, running over 7 years, is attempting to extend the first broad investigation of the impacts of these climate-related and other natural hazards on the economy, society, and history of Southeast Asia from the 10th century to the present, and it builds on a multidisciplinary research orientation concerned with exploring economic and social systems across time in the context of human-environment interaction. And that's the key to the whole project. Now, a key part of the analysis in the project itself involves the evaluation of dominant assumptions about the strengths and weaknesses of local knowledge, that is pre-colonial institutions and colonial agencies, for providing disaster assistance across time and through space. So the project is also comparing and reevaluating pre-colonial and colonial disaster preparedness, relief coordination, natural hazard technology, and politics. Within the framework of the project as a whole, primacy is being given to the role that people in the region, Southeast Asians, have played in terms of local methods of prediction, preparation, and recovery, including the extent to which indigenous knowledge and practices about the climate and the environment were appropriated during the colonial period and then taken up in the 20th century. So that's just a little of the background to this larger project. Now, a little about the paper itself, just a synoptical overview before I begin. What I try and do in this presentation is to fill a gap, in effect, in the historiography of the Philippine Islands. It's attempting to do this because extreme weather events, whether it's in the Philippines or, for example, in Hong Kong or in Taiwan or in Japan as well, especially cyclonic storms, like other environmental factors, are generally considered as a given, as something so common to a particular society, country, or region, as in the minds of many people, to be thought of as truly unremarkable. One of the things that the paper will attempt to do is to note the fact that for all of recorded history in the Philippines, namely from the 16th century on, when the Spanish first arrived in the Philippines, typhoons, in effect, have been the principal natural hazard, a hazard which, by the final decades of the 20th century, is estimated on an annual basis to have caused damage equivalent to anywhere between 6 and 10% of the country's GNP. In the paper, I'll note that in recent decades, the Philippine Islands are now threatened on a regular basis by an average of about 20 typhoons each year. That these generally occur during the months of September, October, and November. And for many of you living in Hong Kong, I'm sure this, the pattern of the season is one that you're thoroughly familiar with as well. Or for that matter, people living all along the China coast. The one other point that I would like to make in the paper is that since the Second World War, that the damage done by typhoons in terms of the destruction of human life and economic damage has increased exponentially. partially because the typhoons themselves have become more powerful, but also because of the fact that the Philippine population has continued to grow. So exponential growth of population. And Manila and other major urban areas continue to expand as the economy in the country has continued to grow. So in other words, the damage done by typhoons more recently becomes even greater because with the passage of time, in effect, there is even more that potentially can be destroyed. And I'll just leave it there then and turn to the paper now itself. So let's go this way. So the Philippines, as you know, is situated between Taiwan and Borneo, with the waters of the Pacific on one side and the China Seas washing its coastlines on the other. Now, due to its geographical location and physical environment, the Philippines historically has been vulnerable to typhoons, to floods, to storm surges and drought. And over the past 5 centuries, typhoons and floods have been the principal natural hazard in the Philippines based on frequency of occurrence, intensity, and impacts. As I just noted a moment ago, by the final decades of the 20th century, typhoons are estimated to have caused 2.4 million pesos in damage over the recent decades, or more or less 6% of the GNP on an average basis. Typhoons or baguios form all year round over the Pacific without crossing north of 20 degrees latitude. Cyclonic storms are generated, as you're well aware, when sea surface temperatures cause warm air to rise, which then develops into a tropical depression, intensifying into a severe tropical storm or typhoon. Wind speeds of these cyclonic storms can now readily reach up to 322 kilometers per hour, or over 200 miles per hour, and are often accompanied by 4.5 to 6 meter or 15 to 20 foot storm surges, particularly along the east coast of the Philippines. Now, when we're talking about cyclonic storms, I think it is important to make a distinction. It was one that the early Jesuits who pioneered the science of meteorology in Asia made between what they referred to as remarkable or destructive typhoons, and those typhoons tended to be of the wind-bearing type, whereas the more ordinary variety they thought of as being the rain-bearing type of tropical storm. According to Jose Coronas, which was one of a series of remarkable Spanish Jesuit meteorologists at the end of the 19th and the beginning of the 20th century, he wrote, quote, "Remarkable typhoons are, quote, one of the greatest natural calamities that may occur in any place, while the latter, or rain-bearing type, provide much of the precipitation so necessary for agriculture." Now, in modern meteorological terminology, a distinction is made between 3 kinds of tropical storms, and it's based primarily on scale and wind speed. So a tropical depression has a maximum winds up to about 63 kilometers per hour, or the equivalent of about 39 miles per hour. A tropical storm has maximum winds ranging from 64 to 118 kilometers per hour, or 40 to 70 miles per hour. And a typhoon has maximum winds between 118 to 239 kilometers an hour, or between 74 to 148 miles per hour. But there is this other category now that has emerged. It's a consistent category now since the mid-1980s. And these storms now that are intensifying in strength, and they're getting bigger as well. I mean, the space that they move across. These are now referred to as super typhoons or extreme typhoons. And these are storms now that exceed usually 240 kilometers per hour, or over 150 miles per hour. Now, the vast waters of the Pacific are ideal for the incubation of cyclonic storms. These storms form in low pressure areas east of the Philippines. The nursery, in the sense that spawns them, is near the Marianas and Caroline Islands. It's in this area where the warm ocean surface, with sea temperatures of at least 26 degrees centigrade, and thick layers of moist air extending to a height of 3 kilometers or more. This is what is sufficient to favor the development of these large storms. The number of typhoons that form in the China Seas compared to the number that form in the Pacific is relatively small. And this has been the case historically as well. A careful study of the atmospheric pressure in the Philippines was crucial in order that the earlier meteorologists could reliably forecast the arrival of a typhoon, ideally in the past several days in advance, before you have certain breakthroughs in technology and over the course of the 20th century. So the kinds of things that the Spanish Jesuit meteorologists in the 18th and 19th century looked for, and here they're appropriating local knowledge. For example, the upper banks of clouds and the color of the clouds, and to a lesser extent, clouds of medium height. This provided additional information, not only to the Jesuits, but to the Filipino people themselves, as to the possible existence, the impending arrival of a typhoon, before it was actually observable, before it actually crossed the coast. The swell of the sea caused by a cyclonic storm was also probably the most important indirect observable sign. Now, the diameter of a typhoon may range all the way from 30 to 40 miles, and that is from 48 to 64 kilometers across, to as large as 1,000 or more miles across now, with a typical width of about 300 miles. In the early years of meteorological forecasting, the smaller storms, and this is quite important because of scale, these smaller storms frequently escape notice altogether unless some ship off the coast accidentally encountered it. The larger typhoons could affect the weather simultaneously across both Northeast and Southeast Asia, and it is still the case now. In terms of calculating the area of the body of a typhoon, the Jesuit meteorologists estimated size only when the storm actually entered the archipelago in the past. It was these smaller storms, however, which the Jesuits rightfully felt posed the greatest danger because they could rarely predict their passage. A big typhoon took a day or two to alter its course, whereas a small one could change direction quite quickly. When typhoons move very slowly across the Pacific Ocean to the northeast and or the northwest side of Luzon, or when they follow one another in close succession in the Pacific itself, or whenever a typhoon recurs somewhere north of the Philippines, there can be catastrophic consequences. And this was often the case in the period before you had reliable ways of predicting or forecasting not only the direction, but the impending arrival of the storms. And across the centuries, then, it's the slow-moving storms that have often proved the most destructive because they usually were carrying a lot of precipitation with them, and they brought then with them the threat of flooding and landslides. Now, a little about seasonal patterns. An average of 20 typhoons nowadays threaten the Philippines each year. The strongest occur between September and November. These recurring storms are generated in a tract of ocean that has become known as Typhoon Alley, or the Typhoon Belt, in which the Philippines is centrally located. This is a belt that stretches between 10 and 40 degrees latitude and is notorious for its high incidence of threatening storms, particularly within the area that, if you bracket it, if you think right across the Philippines, an area that stretches across southern Luzon, and then deep into the Visayas. We can think of it as being a square of sorts that takes in Camarines Norte and goes as far south as eastern Samar. However, up at the top, sweeping in from the southeast, are a lot of powerful storms that hit the northern tip of Luzon and the Batanes Islands, which are about 135 miles out into the sea, Philippine Sea, north of Luzon, where it intersects with the South China Sea. But the highest annual frequency of typhoon passage is in the Ilocos region, as some storms also form west of the Philippines in the China Sea, and then tend to move towards the northeast. And these storms can then either cross over and go up towards Japan, or out towards Taiwan, and then recurve back towards the China coast. Now, in terms of zones of formation between 1880 and 1901, approximately 82% of the typhoons formed in the Pacific, while only 15% of them that were being recorded then formed in the China Sea. A century later, towards the end of the 20th century, the number of typhoons originating over the Pacific has increased now to over 90%, while those forming in the South China Sea has declined to around 7% now. Critical in understanding both the birth of meteorology and its links with colonialism, and how the Jesuits attempt to appropriate the weather in a sense, is the fact that at the beginning of the 20th century, when this new science of meteorology was emerging, the Jesuits could really provide a categorical answer to the path a typhoon was going to take, since it depended on knowing about its origin, about its wind speed during the course of trajectory, and its capacity to change direction or recurve. And it would only be in the 1930s, in fact, that one of the newly arrived American Jesuits, a man by the name of Charles Depperman, who at that point became the assistant director of the Weather Bureau in Manila, he had studied meteorology in Norway, and in fact, it's the Norwegians who pioneer in Bergen what becomes the science of modern meteorology as we know it now. And he studied there under some of the leading Norwegian meteorologists, and they had a school that developed what, for want of a better term, we would call frontology now. I mean, that is trying to predict the weather on the basis of how fronts develop and then move. So Depperman returned to the, he came to the Philippines in the early 1930s with this education that he had acquired in terms of theory and practice about the genesis and paths that storms could take. And he applied it then, not to hurricanes in the Atlantic world or in the North Sea now, but he applied it in a tropical setting to the Western Pacific and to the China Seas. In other words, trying to unravel the genesis and paths of typhoons. And his promising work just prior to the advent of the Second World War then set the stage for beginning to be able to provide more reliable forecasts, not only in the Philippines, but what was referred to then as the tropical Orient, on behalf of agriculture, on behalf of shipping, and on behalf of the birth of aviation in the pre-war years. Nevertheless, I mean, 50 years after Depperman's path-breaking studies, there was still no ready answer when it came to being able to predict typhoon tracks with a great degree of certitude. It's still the case sometimes. One of the most remarkable typhoons of the 20th century, for example, Yoling, started with a slight early morning drizzle on Tuesday, the 19th of November, 1970. There was no warning of an impending catastrophe, except for media reports of an approaching storm. Tragically, the typhoon tracking of the Weather Bureau in the hours just before Yoling struck was incorrect, and the people in the greater Manila area did not receive any warning that a typhoon bearing 200-kilometer-per-hour winds was on its way. The projection gave a plotting that showed an anticipated typhoon path far south of Manila, yet by 10:15 that morning, Yoling was already over the capital and doing extraordinary damage. It battered the capital. It's one of the great storms to hit Manila, and there are a series of them. Again, in terms of the cycles or patterns, when you look at the historical records over time, nature, Mother Earth, the climate and the weather, there are natural rhythms, and they repeat. So there are century cycles, there are half-century cycles, and there's an interdecadal wobble within the framework of the half-century cycles. So Yoling, batters Manila, and in retrospect, it seemed rather odd at the time that with more than a half a century of typhoon tracks compiled and recorded by the Jesuit meteorologists, no one at the Weather Bureau in Manila in 1970 had ever done a statistical study of the mean gradient in the typical typhoon curve based on the historical data that the Jesuits had compiled over more than a half a century. Now, since the 1880s, as each year's typhoon season built to a crescendo, the damage statistics and death tolls showed that even in a relatively benign year, the Pacific summer typhoons were as deadly as they were difficult to predict. The early Jesuit meteorologists of the Manila Weather Bureau had constantly worked to improve their forecasting techniques in order to provide more reliable annual forecasts to the farmers, to fishermen, to merchants, and of course, as I noted before, later for aviators, even though they did not yet possess adequate technology to make such forecasts based, and this is the key thing, based on a dynamic physical understanding of the atmosphere. And the real breakthroughs, apart from trying to observe the weather, will come in the post-Second World War period in terms of the birth of what we call today atmospheric science, where what will be really critical in terms of understanding not only the direction of the storms, but how they develop in size and in intensity, has to do with the study of the ionosphere or the high atmosphere and its relationship with the sea surface temperatures of the ocean, and how the temperatures in the ocean currents oscillate. And I'll come back to this in a little while in terms of the relationship between the storms, historically speaking, and the importance of the ENSO, or the El Niño Southern Oscillation, for understanding climate variability across time and through space. However, some major changes in the monthly variations of typhoons between the end of the 19th and the 20th centuries emerged from their early research. The frequency of monthly variations, for example, between 1880 and 1901, showed that 352 out of 468 typhoons recorded, namely more than 75% of them, took place in the 5 months between July and November, while only 16 occurred between January and March. What's significant here is, in terms of recent analysis of later time periods, it suggests now that the typhoon season has extended deeper into the latter part of the year. Greg Bankoff and others note the fact that a historical comparison of storm events, for example, between 1880 and 1894, shows that the percentage of typhoons in August and September has decreased slightly, while the proportion now in November and December, and even into January now, has noticeably increased. So the season now, as it has normally been defined in the Philippines, but I would suggest it carries over into the South China Sea as well, along the China coast. In the last 3 decades of the 20th century especially, has deepened by at least, well, depending on the time period, I mean, the 5 or 10 years you're looking at, it's deepened by anywhere from 6 weeks to 2 months. According to Pagasa, that is the Philippine Atmospheric and Geophysical Scientific Association, during the post-war period from 1948 to 1994, the Philippines was hit by the largest number of storms of varying intensities in the month of October, with a tally of 37 typhoons, 21 tropical storms, and 15 tropical depressions. This was followed by November with 36 typhoons, 11 tropical storms, and 15 depressions. Again, what's significant here is from an analysis of the data, the highest number of typhoons crossed the Philippines now increasingly as we move closer to the end of the 20th century and into the first decades of the new century, in the period from September to November and beyond. But this was not the case, of course, earlier in the century, when there appears to have been fewer recorded typhoons occurring later in the year. I mean, namely at the end of November and December. So, I mean, the question that immediately comes to mind is why would this be the case? And of course, if you look at the recent report of the IPCC, but all of the weather and all of the data that has been collected over the last several decades about global warming, about which decade in the last several decades, if not the millennium, has been the warmest, which years have been the warmest, and it all points increasingly, to the 1990s and the decade we're currently in, and then to certain sets of years within each of those decades, and I'll come back to that in a minute. Okay, now the use, if we look at the intensity now, the use of the terminology black wind and violent rain to describe typhoons with wind speeds that could reach in excess of 200 miles an hour is both universal and ancient. The term black wind was first used by the Chinese Buddhist pilgrim Fa Xian to describe a remarkable typhoon that he encountered on board a junk in the China Sea in the year 414 BCE. The term black was also used by the medieval Moroccan Muslim traveler Ibn Battuta in his journey to Sumatra, the Philippines, and China in July or August of 1348, in which he crossed the China Sea twice and was nearly cut short, shipwrecked in a sense, by a very large typhoon. Ibn Battuta subsequently wrote, quote, "We had a fair wind for 10 days, but as we got near the land of Tawalisi, that is Sulu, Palawan, and northern Borneo, it changed into violent, the sky became black, and heavy rain fell. For 10 days we never saw the sun, and then we entered an unknown land and an unknown sea," end quote. During the early Spanish period, 16th, 17th, 18th century, letters were often written giving accounts of the way merchant vessels were destroyed or how they struggled against the fury of a typhoon's winds. Letters also contained information about the scale of the destruction done by remarkable wind typhoons. For example, just one example, this is a letter that refers to a typhoon that occurred in central Luzon on the 27th of June, 1639. It overturned houses and did great damage in all the others and to the churches. It blew the tiles through the air as if they were bits of paper. The galleons along the shore were a great cause for anxiety. 200 houses were overthrown in the village of the Indians, Filipinos. But what caused most fear to those natives, and the old men say that they have never seen such a thing or heard it told by their ancestors, is that the hurricane carried into the air the small boats that they use, which are called bancas and resemble canoes. It is said that they were blown about like paper, and that when they fell again, they broke into pieces. Without any doubt, the epithet scourge should be used to describe not only the intensity of the typhoon winds that lashed, in inverted commas, the archipelago, but also the terrifying sound, the constant roaring of the wind that accompanied the widespread havoc. And when you read the Spanish records about these storms, this is the language that they use. And then too, it's tied back to their faith and their apocalyptic worldview that the storms, the reason for the storms in part was Deus Machina, or it's divine retribution for sin usually. But the terms that they use in talking about the wind and its impact is lash usually, or laceration, cutting, and scourge. Some of the highest wind velocities recorded in Asia in the 19th and 20th centuries, however, occurred in Japan and in Taiwan. In the 1930s, a velocity of over 230 miles an hour was reported from Tsukuba in Ibaraki Prefecture. And the Taiwanese records also show wind speeds of well over 157 to 160 kilometers an hour in this period. Now, no such velocities were ever recorded in the Philippines prior to the Second World War. But since then, some of the highest wind speeds in the Asian region have occurred in the Philippines in the second half of the 20th century. Velocities of over 200 kilometers an hour, 125 miles per hour, have become increasingly commonplace in the 1980s and 1990s. So this table here shows the increased frequency of typhoons with extraordinary wind velocities. It lists the 25 most intense typhoons in the Philippines between 1951 and 1998 in order of wind speed. Since 1970, there have been 16 typhoons with wind speeds in excess of 200 kilometers an hour, 8 with velocities ranging between 220 to 240 kilometers per hour, and 4 with maximum wind speeds between 250 and 275 kilometers per hour. What is clear is that the majority of Philippine typhoons with the highest wind velocities have occurred in the Bicol region, which is southern Luzon, and off the coast of southern Luzon in the Catanduanes Islands. The Catanduanes, for example, have been devastated 4 times by extreme typhoons in the decade between 1988 and 1998. The table also indicates that since 1976, the wind speed of the typhoons has increased by 10 kilometers, or 6.2 miles per hour, or more each decade, and has nearly doubled in velocity between 1947 and 1998. In the final third of the 20th century, increasing numbers of cyclonic storms are now rated as superstorms, and this means that these storms have at least 1 minute sustained winds of more than 240 kilometers per hour, and that they now strike the Philippines regularly on an annual basis. During the 1980s, this was a particularly excruciating period for the Philippines. There were 4 super typhoons with wind speeds between 240 and 260 kilometers an hour that hit the archipelago between 1981 and 1987. while 5 other extremely strong storms also struck the Philippines during the 1980s with wind speeds between 210 and 230 kilometers an hour. And this is not surprising because in terms of the variability of the global climate, climatologists and meteorologists only began to really understand the teleconnected nature of weather systems around the globe after 1983, when they realized for the first time the significance of the El Niño Southern Oscillation and how it worked globally. The vulnerability of buildings to high winds in the Philippines and elsewhere has historically depended upon the strength of materials and design, the age of the facility, and its site exposure. High occupancy buildings in the Philippines, such as town halls, churches, convents, and schools, historically were often used as storm shelters and evacuation centers. However, their collapse and destruction due to typhoon winds or flooding, especially in recent decades, as has frequently occurred in the 1990s, has caused considerable loss of life and had a severe adverse effect on the social life of the communities that have been impacted now by these recurring and sometimes tightly spaced successive superstorms. The increasing force of the winds of extreme typhoons would progressively destroy entire communities in the 20th century as population densities increased and high-risk structures built of questionable materials were constructed in old neighborhoods, slum areas, and built-up zones of mixed development. In the 1990s, the impact of cyclonic winds on major cities and commercial centers in the Philippines has been grim, to say the least. And I've had direct experience of this on several occasions in the Philippines when I've been working in the archives in Manila, where it's been impossible because of the flooding to get back to where I was living, up España near the Rotunda. You just camp out in the archive. I mean, the water rises up over the steps. They put a plank down. It was, it's like a scene out of Pirates of the Caribbean. If you're game enough to try and walk out, on several occasions I've actually done that in the past, where I've rolled my pants up to my knees, walked out into Callao, and then tried to find a jeepney driver that was game enough to drive through the floods to get back to where I lived. And on one occasion we managed, and on another occasion we didn't. So yeah, but it's not pleasant, and I really feel, for people who have to deal with this now all the time on a daily basis. It's not just a week or even a month now. There are certain places in the Philippines now where the floodwaters don't recede for a variety of reasons anymore. The natural capacity is no longer there. It's either been, concreted over, or the direction of the rivers has been a whole variety of things where we've changed the character, the topography of the landscape, which just allows the water to sit there and build up. So it can be months now. In certain parts of Pangasinan, the floodwaters are above the level of the windows of the house for 4 months of the year now, sometimes longer, 5 months even. So in the 1990s, then, the impact of cyclonic winds on major cities, commercial centers, on communities right across the archipelago, it's been devastating. For example, on the 13th of November 1990, when Super Typhoon Mike slammed into Cebu with peak winds of 254 kilometers an hour in the central Visayas, Cebu being the nation's second largest city in a thriving economic area, all of a sudden, literally overnight, it was instantly cut off from the outside world. All communication, the telephone poles, all the electrical systems, everything just collapsed, shut down. It left over 370,000 people without their homes, affected millions of people, caused tens of millions of dollars worth of damage within the space of several hours.
Quote, "It's like an atomic bomb has hit us," Senator John Osmania stated after visiting the devastated city. "There is no electric post standing. There are no trees standing. There is no light. There is no water. There is no telephone. There is no gasoline." And it's under such circumstances, confronting the annual passage of these powerful storms now, that the period of time between them since the late 1980s, but especially since the late 1990s, is closing. It's closing. That is, in the 16th and 17th century, recurrent successive large storms came in gaps of 5 to 7 years. By the 19th century, it's down to 3 to 5 years. At the end of the 20th century, it's 3 years. And the climatologists are predicting by 2025 and 2030, the gap in the oscillation will have closed, and what we consider now to be extreme or aberrant is going to be normal. It's going to be normal. What you should understand, though, for many people in the Philippines or in certain parts of sub-Saharan Africa at the moment, in terms of the alternation between drought and flood, or in certain parts of Brazil and the Amazon and the Mato Grosso, people who have deep, abiding ecological knowledge, whose lifeways, whether it's agriculture or fishing, have depended on understanding the environment. It's close to their heart spiritually and practically. They now cannot understand what is happening, because when the rain is meant to be falling, it's dry. And then conversely, in places that are semi-arid, where they grow crops that are climatized to that situation, now there's flood. And everybody is being so adversely affected. In this kind of situation, where you've got this kind of annual passage now of these powerful storms that are coming successively now in sets that are tightly spaced, frequently with limited warning, for the Filipino people, who are particularly devout people, for them, in many instances now, all they can do, given the constraints, the capacity of a government, whether it's a strong government or a weak state, to mitigate, in a sense, to provide relief and recovery, all they can do is pray for mercy or pray for a miracle. And who they pray to is Santa Potenciana, who historically has always been the patron saint of typhoons. And so in the 16th and 17th century, the lifeline for the Philippines then, in terms of the trans-Pacific connection between China, Manila, and Mexico, the longest, most profitable, most perilous voyage in the world at that time, like sailing through interstellar blue space. The oceans then were not completely known. Longitude had not been discovered yet. So it took a lot of courage, to set out across the Pacific, and you're confronting these storms. On the vessels, on the galleons, they crossed these waters in the 17th century. They carried the Sitawado, great silver from Mexico and so forth, the gross national product of the Philippines, effectively, from one year to the next. On the vessels, they always had a statue of Santa Potenciana. Yeah. And in terms of trying to reconstruct the storms over time, a lot of the material, that I've collected, the Proxy records in the Spanish archives over many years, that data comes from the records of naufragios, or the shipwreck of the galleons themselves, when testimony would be taken down from the castaways and the survivors. It also comes from those people who were on the vessel sometimes who didn't survive, like Jesuits going from China to Manila and from Manila to Mexico, and ultimately hoping to return home to Spain. But they drowned in a storm in the Pacific. So to venerate their memory then, the Jesuit order incarnated them as martyrs. And then there are biographies of them, and the biographies themselves, in talking about their lives, also mention the storms. So again, this is another place when you're looking for data in the era, the pre-instrument era of observation. This is one example in terms of proxy records where you can go to try and find that kind of information. Of course, on the China coast, we can push the time scale back much further because of the relationship between the emperor and what we can call a moral meteorology, the link between climate variability and agricultural productivity, and the moral responsibility of the emperor to make sure that there's harmony across the empire. So the mandarins, in their reports and in the gazetteers, always recorded meteorological events, earthquakes, eruptions, flood, storm, anything that upset that harmony. So in the Chinese records, it is possible to build up time series that actually can take you back over 1,000 years. And there's been some very interesting work done by a range of Chinese meteorologists, both in the United States and elsewhere. It's referred to in disciplinary terms as paleotempestology, where they're looking at the old records to try and recreate storm cycles, but they then also go to sites along the coast and they take core samples and so forth to see the way the coastline has been affected by either tsunami, hurricane surge, or the storms themselves. Okay, now we'll go on to, so over the centuries then, the Philippines has suffered from typhoons coming ashore in rapid sequence, especially, as I've noted, in more recent time in the period toward the end of each year, from October through December. Not only are these late season storms deadlier than their earlier counterparts, but they also generally make landfall within a week of each other. So flooding and torrential rainfall due to tightly spaced sets of successive storms, as I've tried to stress, has intensified in the 20th century in the Philippines, also probably in Hong Kong, as well as along the China coast and parts of Vietnam. Although rain typhoons may cause less damage than the furious energy of the wind typhoons, the rain typhoons carry much heavier rain loads. Throughout the first 3 decades of the 20th century, typhoons making landfall in the latter part of the year were not only usually more destructive than typhoons crossing the Philippines earlier in the year, but they also frequently came ashore in rapid succession, causing widespread destruction, as I've noted, to buildings and agricultural land. This pattern has continued the reoccurring effects of tightly spaced typhoons throughout the 1990s, while the cost of the damage caused by their regular reoccurrence has become astronomical. It has escalated. So for example, on the 5th of December 1993, Typhoon Lola crossed near Manila, dumping over 500 millimeters, 10 inches of rain in places in less than several hours. This is as much rainfall as falls in southeast England in a year. And the damage due to flooding was extensive. In September 2009, the main rains spawned by Typhoon Quetzana or Andoy in Metro Manila were the highest to have occurred in 42 years. And just as a footnote here, Andoy more or less wiped out the press that I have published all my books with in the Philippines over the past 4 decades. That's New Day Publishers. I mean, they are still in business, but barely so. I mean, they're trying to get back on their feet, and it's still not there. The flooding destroyed the offices, it destroyed the warehouse, and it destroyed my new book that had just been published. In fact, the biggest hit they took financially, there was nothing I could do about it in terms of the timing. It was most unfortunate conjuncture in that respect. Had to do with with my most recent book at that point, and they had invested heavily in it, and they had, you know, printed a large print run, and it was just sitting there ready to be distributed, and Andoy came, you know. What's significant about Andoy, though, is the fact that 8 days later, another typhoon, Parma, arrived that was as large as Andoy, and again, it did not spare Manila. I'll move on. I mean, I think I've tried to make the point here about escalating costs and the reoccurrence. So let me just say a little about impact now, not on infrastructure, but on agriculture. So if we move down into the 20th century, and look at the impact of these storms on areas in the Philippines that developed over the course of the 19th century and the 20th century. In the second half of the 19th century and into the first half of the 20th century, the Philippines is integrated into a global commodity. And part of that integration is linked to the development of monocrop agriculture under colonial rule, which changes the relationship that Filipino people ordinarily had with their land. Among the key crops that are promoted and developed are abaca, coffee, sugar. I mean, they're the key ones, and to a lesser extent, pepper, which doesn't do as well. But nevertheless, there was an effort made to do it. Cocoa also, to a certain extent. But inextricably bound up with these crops and the welfare of the Filipino people historically, in terms of subsistence, is rice. And the relationship for many Filipinos between their capacity or their ability to continue to cultivate rice at the same time now that they are increasingly involved, integrated into this colonial economy, is quite significant. So let me just give you one example relating to rice bowl areas in the Philippines, which is in southern Luzon, again in Bicol. So in 1934, for example, you have 4 typhoons that cross in quick succession in October and November, and they cause extensive flooding to the extent that it inundated almost and submerged all of the rice lands of southern Luzon. Not only inundated them then to the point where the harvest was lost, but in the process of doing it, because of the scale of these storms and the fact that they came so quickly, so rapidly on top of one another, and created this long flood, if you wish. It's one continuous flood in one sense. You could almost make an argument, and I will do this maybe in the book when it's finished, hopefully next year, like an argument that Oliver North makes for earthquakes in Peru, that when we're talking about cyclonic storms and we're talking about the longue durée in Brodelian terms, we're talking about a storm that occurs over a 500-year period. Yeah, it's one continuous, one long storm in a sense in that way. So what happened here in 1934 was, beyond the actual inundation, great quantities of sand and eroded rocks and stones were washed down off the slopes of Mount Mayon, this huge volcano. And it rendered then the rice fields that, ecologically speaking, had been built up over a millennia, over a long period of time. It rendered them unproductive now for decades to come. In other words, the yields now were dramatically diminished as a consequence of that. It was not that they were completely destroyed, but the capacity to grow rice and sustain the population was no longer the same. So the human suffering and crop damage associated then with extensive flooding and devastation such as occurred in 1934 It also then has to be, and I can't go into it here, it's also inextricably linked to what I would call a political economy of death. It's linked directly to hunger and food insecurity. Again, in early September 1998, when Typhoon Babs arrived, it came on the heels, we'll go back one minute. It came on the heels of Typhoons Vicky and Zeb. When it swept through the Philippines, these three storms destroyed, in less than 3 weeks, 734,700 tons of rice, which was worth over $42 million US. In the aftermath of it, again, as was the case in 1934, many of the areas directly affected were aggravated for several years afterwards in terms of their capacity to grow rice normally, to the extent that many of the people in those areas, despite assistance from the government, were now forced to subsist during those several years on eating banana shoots and trying to grow tubers because they couldn't grow rice anymore. At least not then. Okay. Now a little to kind of move towards summing up here about peaks and patterns that across time. The intensity of tropical cyclones crossing the Philippines has gradually increased from the middle of the 18th century onward, right down through the 19th century. But in terms of cycles of intensity, we know from the historical record that, for example, from 1850 until 1899, there was a marked steep increase in the number of typhoons per decade. What this graph shows is the frequency in the periods between 1780 and 1799, 1830 and 1849, and 1880 and 1899. That's quite significant, and it's tied back to half-century cycles and full-century cycles. Further along. So this graph lists 54 storms and typhoons occurring between 1870 and 1879. Between 1880 and 1899, there were 69. While between 1890 and 1899, there were an amazing 83. The northern end of the Philippines and the southern tip of Luzon and Samar, the eastern side of the Philippines, suffered acutely from this periodic cyclonic activity. And it's not surprising that it's precisely in these areas, southern Luzon, eastern Samar, these are the areas historically also where millennial movements developed across time. These are also the areas in the Philippines where historically the New People's Army has been strong and still remains strong. So there are questions that are raised there about meteorological politics and the capacity of a government or a state to provide certain kind of social services. And if the state is weak for whatever reasons and cannot provide appropriate mitigation, then how do people respond to that? In some instances in the past, they had recourse again, spiritually, but in terms of the vernacular, not in the Catholic context. More recently, it's another kind of theology, that was linked directly to Marxism. But what's important to note here is, again, in terms of the typhoon alley or the typhoon belt, where these storms come through, it's precisely in those areas that are bracketed by the storms. These are the areas that historically that suffer socially, culturally, ecologically, economically across time. Yeah. Okay. We'll be on that. No, let me go back. Okay. Now, in the period from the 50s onwards, the annual average of typhoons crossing per decade in the latter half of the 20th century has varied between just over 18, between 1950 to 59, to just over 20 in the decades between 1960 and 1989. While between 1990 and 1999, there have been an average of about 18.5. Now, when comparing earlier accounts with the annual frequency of tropical cyclones crossing the Philippines between 1948 and 2000, the trends in the meteorological record shows cycles of increased frequency spaced about a decade apart, which seem to occur in the early years of particular decades. The pattern of this activity is most pronounced in the 2 decades just prior to mid-century and the 2 decades at the end of each century, which constitute part of these major cycles. And it's fascinating, actually, when you go back and you start to look at major events in the record before the era of instrument observation. And it's like clockwork. 1781, 1832, 1832, 1881, 1881, 1932, 1932, 1981, and then it goes haywire. 1983, the weather globally really now starts to change quite dramatically and become aberrant in some ways, yeah. But what the meteorological instrument records and the other proxy records of past weather reveal is the increased annual frequency that is part of both 50 and 100-year cycles. So I'll move forward here. Yeah, so it gives you some idea of the pattern. What's important in terms of trying to understand these cycles is why particular years over the centuries have been active in terms of cyclonic activity in regard to frequency and intensity, and while other periods have been relatively benign or calm. It has something to do with the working of the ENSO, or the El Niño Southern Oscillation, and or with global warming. Climate not only varies from one year to the next, but it can change to a new multi-year average and then stay that way for longer or shorter periods of time. The link between El Niño events and typhoons, there's speculation around it, but climatologists have pointed out that El Niño years usually have fewer typhoons, while anti-El Niño, or what are referred to as La Niña years, have more of them. I mean, these are wet periods as opposed to dry periods. Like global warming, El Niño, or more precisely, the climate cycle that produces El Niño, does not generate weather per se. Rather, it promotes the growth of the context in which the weather takes place, which gives birth to the weather. Historically, climatic indicators of an El Niño event in the Philippines include weak typhoon activity, fewer numbers of typhoons entering the Philippine area of responsibility, and less intense typhoons. So if we go back, let's see, no, we gotta come forward here a little. Yeah. So historically, climatic indicators of an El Niño event in the Philippines, which I've mentioned, include weak activity, fewer storms, and less intense storms. The table below indicates that annual typhoon numbers between 1880 and 1889 range from as few as 11 tropical cyclones in 1880, 1882, and 1885, all El Niño years, to as many as 28 in 1887, which was a very strong La Niña year. The annual tropical cyclone frequency between 1880 and 1898 in graph 3 indicates that there was less typhoon activity during 5 El Niño events. That is 1880, 1882, 1885, 1888, and 1896, with the exception of 1891 and 1894. The El Niño year of 1891 had followed closely on the heels of the impact of a strong La Niña event the previous year. That is 1890, where there had been 27 typhoons. La Niña years favored tropical cyclone formation over the western Pacific, which tended to increase the annual frequency of typhoons in the Philippines from 16 storms in 1886 to 28 storms the following year. There were 27 typhoons in 1890, 24 in 1893, and this was then followed by a record 34 typhoons in 1894. So, let me just finish up now. What the graphs that I've put up in PowerPoint form here tend to suggest that is over the centuries, beginning in the 16th century, there is this pattern. It's a pattern, it's cyclical, it operates on a century basis, and it also operates on a half-century basis. It's a pattern that right up to the present is still fairly reliable, naturally speaking. These large storms come at intervals and they hit Manila. And they've done it on a half-century basis now for almost 5 centuries. But then there's this issue too, even still in the Philippines, but elsewhere in the world too, of a kind of structural amnesia, where people only think of the storm as it is approaching in terms of its size as being a once-in-a-century storm, or a once-in-500-year storm. What they don't really recognize or fully understand is it's part of a cycle that has been occurring for centuries. It's just that it hasn't been fully explored or reframed and presented in a way that people can readily recognize and understand it. So in short then, the storms, they occur in 50-year cycles with clusters of powerful storms and highly variable climatic activity occurring towards the end of each century. Now globally, I can't go into that here either. I find it fascinating both in the Philippine context, but right around the world, that the really bad weather, a lot of the major global historical events that have occurred in the last 2 decades of each century, whether it's the 16th, 17th, 18th, 19th, or our own century, I mean the 20th. While it is not clear in what caused these cycles entirely, integrating the earlier meteorological record with historical accounts and current climate research certainly will help us to better understand how El Niño periods and other climatic mechanisms, such as atmosphere control, have been largely responsible for much of the major weather phenomena we're experiencing at the moment. On average, the Philippines experiences just under 20 typhoons a year, except in 1993 when there was a record 32 typhoons. And again, the pendulum swing here of various sets of El Niño, La Niña periods spaced up to a century apart. If we look at 1791, 1798, 1891, 1898, 1991, 1998, the devastating impact of the events that occurred in these tightly spaced periods over the course of 3 centuries in 9 years is something that needs to be reassessed and re-examined. And in doing this, while we have to take into account the meteorology and the climatology, we also have to take into account the imposition of colonial rule, the exponential growth of population, and the ascendancy right around the globe of mineral and resource-based economic development, and notably, especially, the taking down of the great forests of the world. Yeah, okay, yeah, so that's it, yeah. Now, I must say, this is certainly the presentation is all about the weather in a sense. It's more about the weather on this occasion than it is about the impacts. So the research relating to this is part of a manuscript. It's been a long time in the making. It's finished. It's 22 chapters. It's a very big book with a lot of empirical data supporting some of the chapters. But I still have 3 more chapters to revise, in a sense. I'm getting close to the end of it, to try and bring the length of the book down and try and make it more accessible, in a sense, to as wide an audience as possible in terms of the real underlying message in the end about consumption, about sustainability, and about the relationship between the world that we have made and the world that we're currently living in, and the fact that at the moment, whether we realize it or not, Mother Nature is on the rampage.
Okay, thanks very much.
Sure.
We have time for just a few questions. Kara?
If I may pick up from where actually you were saying that there is space for more in the manuscript about impact.
Yeah.
I'm fascinated by the historical sources,
Yeah.
in the history and myself.
Ah.
And I was wondering, how is the interaction between description of the upcoming storms with, I don't know, contingency plans or
Oh.
description of the impacts? I mean, what were the Jesuits doing with all
Yeah.
this observation?
Well, the Jesuits are there from the 16th century on, and the history of the Jesuits in Asia, and the history of the Jesuits in relation to science more generally, whether it's botany, whether ultimately it's seismology, astronomy in China. I mean, that's a huge subject in itself, and the network among the Jesuits right around the world, writing to one another, But the Jesuits, especially in the latter part of the 19th century, the Spanish Jesuits, when they're trying to appropriate the weather in a sense, when they're trying to predict the storms, the 2 leading Spanish Jesuits who pioneered meteorology, Alguay and Selga, both of them had a deep appreciation, respect, understanding for local knowledge. So, they went to the Filipino people who lived along the coast, and they asked them about how do you know when a storm is coming and so forth. And so a lot of their information, like on cloud formation, the color of the clouds in relation to the intensity of the storm, information about coastal currents, an impending hurricane wave, this all initially came from local people. And then so there's a kind of pre-Hispanic meteorology there that they build on, and there's a vocabulary that goes along with it for different kinds of, again, grading the intensity of a storm and its scale. And then when the Jesuits begin to obtain certain kinds of technology, instruments and so forth, to begin recording in the beginning of the 20th century, what they do then is they train local people to use these instruments, and they set up observation posts all across the archipelago that then they try to link together in a network of communication that ties the archipelago together and gives them, if you wish, a monopoly, a lock on this knowledge, but also then links the Jesuits in Manila to Hong Kong and to the China coast, to Shanghai, through the cable. And there you're getting into, the weather and empire, colonial politics, and so forth, But the sources, this one Spanish Jesuit especially, I've got for all of them, but great respect and admiration for them. I could not have attempted to write this book without the work that they did. But Selga especially, if I could have been born at the beginning of the 20th century or the end of the 19th century, the questions that he asked, when he would actually go out into the field to certain parts of southern Luzon with a series of questions about the changes in the topography, about the periodicity of flood, about how the contours of the river had changed and so forth. And he did this everywhere. He was extremely prolific. He wrote what he called notes, hundreds of them, on particular events, as well as very well-researched monographs too. The tragedy of the Jesuit contribution to science in Asia more generally, which was based primarily in the Philippines at the Manila Observatory. They had a library of several 100,000 volumes that spanned the period from the 16th century right down to the beginning of the 20th century. But then during the Second World War and the latter stages of the war, in the battle to gain control of Manila, it was like Stalingrad. It was, and certain parts of Berlin in 1945. It was street to street, house to house, and it was bitterly contested and fought over. And the Japanese, and that's another story, I mean, because you can't go into it here, but the Jesuits had formed close relationship with the Japanese scientists in Japan in terms of the birth of meteorology too. So when the Japanese come to the Philippines, they accord the Jesuits special privileges in thinking that they're going to cooperate in the greater East Asian co-prosperity sphere, and the Jesuits will set up a meteorological web on behalf of the Japanese that will cover the whole region. But they don't do it. The Jesuits, in fact, tell the Japanese to get off their property because it's royal pontifical property. And it worked. I mean, at least for 2.5 years. And then the Japanese really cracked down on them. I mean, the Kempetai came knocking on the door one day. But even then, they were able to invoke papal immunity. So, you know, unlike what happened to some of the American Jesuits who wound up in what were effectively internment or concentration camps in the Philippines, the Spanish Jesuits were simply sent back to their convents in a sense, and they had to stay there until the end of the war. But when it finished, the Manila Observatory, the Japanese deliberately covered it in kerosene, set dynamite throughout it, because they didn't want it to fall into American hands. They knew the records there were very important to the United States in the final stages of the war, preparing for what the Japanese thought was going to be the invasion of Japan. And they saw the meteorological data as being very important to both American naval power, but also to American aviation, particularly American long-range bombers, B-29s and B-17s. So they destroyed it. And you know, with it, they destroyed, you know, the library and all of this data that the Jesuits had collected at the micro level, empirical data from the observation post. But fortunately, the Jesuits published in the period from 1902 to 1940 a monthly meteorological bulletin. So rainfall patterns, information on the frequency of the storms, that's there in broad brush in a sense. But all of the micro data that was coming from the observation posts in the provinces and all of the qualitative information that accompanied the data from these local observers was lost. And you get tantalizing glimpses of it in the monthly reports, you know, where they'll talk about a particular storm or a flood, where they'll summarize, like the really great typhoon of 1928. And incidentally, there was another typhoon in 1928 at the same time on the other side of the globe in Puerto Rico, a great hurricane. And again, this is the Tele collection, atmospherically speaking. So there's a wonderful comparative study to be done there about, you know, anyway, I don't want to go there. In terms of Spanish colonial rule, Jesuits in Cuba, Jesuits in the Philippines, atmospheric science, and how two former Spanish colonies, now both under American rule, respond in very different ways to this storm, these two storms on opposite sides of the globe. Yeah.
Paul?
Yeah, this pattern.
Yeah.
You can see how someone might be skeptical. Of
Skeptical?
Of the kind of exactly a century,
Oh, yeah.
91 to 98.
Sure.
So I just wonder how far you've tested it through statistical analysis or talk to quantitative meteorology kind of people?
Yeah, well, I mean, I've been talking today with Professor John Chen, yeah, you know, and he's quite, he's really interested in the work, you know, that I'm attempted to do. I mean, I think in terms, I cannot completely explain the pattern. I mean, what is becoming clearer, and it's coming from other historians, but it's also coming from the climatologists, the modelers, the meteorologists, is the impact that the ENSO has had as the key significant factor. I mean, you could call it the fudge factor in a sense, in terms of affecting the variability of weather over time or contributing to certain kinds of patterns. I mean, it seems so striking to me when I look at the material that I've gathered now over a quarter of a century, and when I put it all together and I look at what's occurring in the Philippines at certain moments in time, in terms of settlement patterns, in terms of population movement, in terms of resistance, in terms of food insecurity, in terms of integration into the global economy. All of those factors are critical, crucial in understanding transition and transformation in the archipelago across time in relation to the climate and weather. But then, what is it about the fact that it seems to be, it's in, these last 2 decades? And, whether it's the French Revolution and, the bread riots, I can think of, in global terms again, right around the globe, 1796 to 1799, it's an El Niño period around the globe, and there's severe drought. Severe drought. You can think about it in isolation. In Australia, when the first convict settlers arrived in Port Jackson, in Sulu, that I'm very familiar with, in the southern Philippines, devastating drought in that period. In eastern Indonesia, under the East India Company and Raffles in that period again. In South Asia in that period too. And this is where Mike Davis makes, in the late Victorian Holocaust book, he's looking just at, one period between 1872 and 1878, where you get these 3 tightly spaced El Niños, and how devastating that was in teleconnected terms right across the equator, just a few degrees above it and below it, right around the globe, from Brazil to China. 50 million people die, but it's not just because of that event, it's because of the way then various colonial rulers and or institutions respond to it, or don't, deliberately. And that's about the political economy of death. That takes you into a Amartya Sen,
Okay, but if 1798 is like the Industrial Revolution,
there's that too, that's right.
How come there's still a 100-year cycle before it and after?
How come?
How come there's still a 100-year cycle before and after? I mean, there seems to be no impact of human activity in that cycle.
Not the way it's portrayed there, because I haven't talked about that. That's the other half of it. This is all the weather, where are the people, where's the the transition? No, the cycle, it's a 100-year cycle, but the 100-year cycle doesn't quite work the way you've just described it now. What I'm highlighting is the fact that for whatever reason, it seems that the data is suggesting that the final decades at the end of each century are really bad. They're really bad. It's not just cyclones in this case, but it's also periods of drought and so forth. And there's work that's been done by environmental historians Fagan, Jared Diamond, yeah, I mean popular ones, but others as well. Lamb, where they're talking about the fact, like in the 17th century, for example, once you get into the 1660s, from the 1660s right through into the 1690s, but especially the 80s and the 90s are a very bad period in Europe, and that, you know, yeah. And then that, you know, ties back to the Little Ice Age perhaps, and, you know, and then, yeah, so.
Bill?
Yeah, you did mention politics a couple of times, so I wondered if I might ask a political question.
Sure.
And it would be this. Do we see any differences in levels of preparedness and recovery across different parts of the Philippines? And I'm wondering, are there different clans that respond better, perhaps?
Yeah.
Are there maybe different municipalities that are more effective in their response? Do you see that across places like Ilocos and Bicol? That was the other one in Luzon, right?
No, that's a very good question. I mean, in fact, in the Philippines, I mean, in terms of, again, disaster mitigation and assistance and the role of NGOs, for example, that the role they come to play within the context of state making too is such that the Filipino government and the NGOs now are a model in a sense. They go to other places in the region to teach the techniques now in a sense about, you know, what you do and so forth in a situation of calamity. The role of, again, I mean, the role of the military here, historically, you know, you go in an earlier period, in the Spanish period, it's what I call the tyranny of inertia. In the American period, with changes in technology, different system of administration, introduction of education and so forth, a different kind of mission civilatrice in a sense. You've got airplanes, you've got the United States Navy there that's prepared to help out. You go from the tyranny of inertia to the tyranny of urgency, where for the first time, you know, through the cable, for example, in southern Luzon, the Jesuits in Manila learned, you know, that there's a storm, you know, it's flooded the province. The Jesuits turned to the American naval commander in Manila. The next day, a destroyer is sent there with a huge amount of rice. At the same time, an airplane does an overfly and photographs the entire area. The Spanish never did anything like that. It's not that they, you know, they did have some kind of technologies that could have helped. At the local level, in terms of your question of, you know, living under the shadow of the volcano, there are certain places, like in the Batanes, for example, off the northern tip of Luzon, where the islands sit at the junction of the China Seas and the Pacific Ocean, where the storms, the top rung of the storms coming through, they're really strong. They're big storms. There's nothing to stop them. You know, a storm hits the island of Luzon, it starts to lose a little of its strength as it moves over the land. If it gets across the island, it gets a second wind as it starts into the China Sea. But across the top, in that open water there, they're powerful storms. Now the people in the Batanes, their culture in a sense, the homes they build, when they fish, what times of the year they fish, the kind of boats they constructed and so forth, are all geared to adjust to living in an environment where these powerful storms are a part of their way of life. Yeah, and they're, in other places, you know, the homes that Filipino people build out of bamboo, I mean, you know, that you can take them apart and you can put them back together again. And this is just it's a bit like Japan during the Edo in terms of, it's the title of a new book, an edited book, an important book called Flammable Cities. But the idea with the shoji screens and everything else about a small Japanese house was that, you know, when a fire approached in the Tokugawa period, it was very easy. And of course, the zen of carpentry in Japan, I mean, the wonderful carpentry where you can take it apart literally and put it together, where everybody in the family in the neighborhood, they had fire wardens, would dismantle the house and run to the river with it. And, you know, just stay in the water there. And then when the fire passed, they would go back and try and rebuild again, but they'd have all the elements to build the house. Now in the Philippines, in certain places, they literally can move a house or rebuild a house, you know, bamboo house. You can lift it off the ground and you can carry it to a new location. The problem was over time though, and especially with the deforestation that has occurred, you know, the plundering of paradise in the last four plus decades, that a lot of the materials that are really required to do this, that enable people to get back up on their feet again, the local materials, the cane, the bahuku, the poles, everything they need, there's less and less of it. And in some areas that historically have been most vulnerable, it was already gone over a century ago as a consequence of migration patterns and the integration of people into the global economy through monocrop agriculture, where they just cut it all down to clear the land to grow something else for cash.
Thank you very much, Jim. for-
Thanks for going the distance. Let's hope it's not raining outside. Yeah.